Good morning to all of you. This is Dr. Bhima Prakash from JIT Anantapur, working as assistant professor at the Department of Mechanical Engineering. Today we discuss about the basics of thermoengineering, thermodynamics. Let me move on to the topic. What is the thermodynamic? Thermodynamics in physics, it is the branch that deals with the heat, work, and temperature, and their relations to the energy, radiation, and physical properties of the matter. It explains how the thermal energy is converted to the one form to the another form of energy, how the matter is affected by this process. And the fundamentals of thermodynamics mainly it is as follows: thermodynamic system, thermodynamic functions, and thermodynamic properties, fundamental laws of the thermodynamics, and thermodynamic relations and thermodynamic process. We discuss one by one. What is the thermodynamic system? Thermodynamic system is defined as a quantity of fixed mass and identity upon which attains is focused for the study, and everything is external to the system is simply considered surroundings of this thermodynamic system can be further classified into the open system, enclosed system, and isolated system. Thermodynamic systems are isolated. What is the isolated system and what is the closed system and what is the open system? Isolated system is an isolated system cannot exchange energy or mass with the surroundings. For example, the universe is considered as isolated system, and closed system across the boundary of the closed system, the transfer of energy takes place, but the transfer of mass does not take place. So, for example, refrigerators, compression of gas in the piston cylinder assembly, uh, piston cylinder assembly are examples of closed system. In an open system, the mass and energy both may be transferred between the system and surroundings. For example, a steam turbine is an example of open system. Heat transfer, what is the heat? Heat is the energy transfer. Heat is the energy transfer between the system and surroundings by the virtue of the temperature difference only. Heat is a way of change the energy of a system by the virtue of the temperature difference only. Any other means for changing the energy of the system is called work. Thermodynamic functions. There are two types of functions defined in thermodynamics: path function and point function. What is the point path function? Is the path function depends on the history of the system. Examples for the path function are work and heat. The point function does not depend upon noise and only depends upon the state of the system. The examples pressure, the temperatures, and density, mass, and volume. The thermodynamic properties. A property is any characteristic or attribute of the matter which can be evaluated quantitatively. The thermodynamic property depends only on the state of the system and independent of the path by which the system is arrived at the given state. The all the thermodynamic properties are the point functions. It can be either extensive or intensive properties. The fundamental laws of thermodynamics, all the thermodynamics can be explained in terms of the four quantities only: the temperature, internal energy, entropy, and heat. The thermodynamic laws is mainly we are focused on the zeroth law, first law, and second law of thermodynamics. The zeroth law of thermodynamics, how the statement is: if the objectives A and B are each in thermal equilibrium, with the objective C, then A and B are in thermal equilibrium with each other. Just we observe the objectives 1 and 2 and 3. Just 2 and 3 are in thermal equilibrium with 2 to 1 and 3 to 1 also in thermal equilibrium. The first law of thermodynamics is it involves the internal energy. The first law of thermodynamics is applications of the conversion of the energy principle to the heat and thermodynamic process. Q is equal to delta U plus IA is available energy. The heat is added to the thermodynamic system, goes to the change the internal energy and to do the work by the system. And this first law of thermodynamic system, how the mass is added from one to another, how the energy, the work transfers and energy transfers. Just we observe this is state one to state one and state two, how these mass and volumes and pressures are the things. In state one is we are added the mass and the piston. What happens? The pressure is increases and the volume is decreases. The volume is decreases and how the internal energies take place. Just we observe the E1 and E2 and kind of by concentration of the heat values and energy values, that is equal to U2 E suffix 2 minus of E1 is equal to Q1 minus of W. And process terminology, mainly these are adiabatic process, isothermal, isobaric, and isochoric. Adiabatic is no heat transfer takes place, isothermal is constant temperature, isobaric is constant pressure process, isochoric is constant volume operations. And adiabatic process is delta q, okay, q is equal to 0, that is the internal energy. Q is delta q is equal to W. Here in adiabatic process, in this negative energy, when the system is expanded adiabatically, delta Q is negative, and when the system is a compression process, delta U is in the positive sign. And isothermal of process is in this isothermal process, the temperature is constant, therefore in the ideal gas, delta T is 0, so that the internal change of internal energy is 0. Therefore, in the ideal process, Q is equal to W. And isobaric operations and isobaric process is a constant pressure process, that is delta U, W, and Q are generally non-zero values, but calculating the work done by the internal gas is the straightforward directly. W is equal to PV into delta T. PV, P into delta V. The water boiling in the, this is one of the operations. And isochoric system, isochoric is in this isochoric is the constant volume operation. This is in this case, the isochoric operation is a constant volume operation. When the volume of the system does not change, it will do not know will it will do not no work on the surroundings, that is W is equal to 0. Delta U is equal to Q. Heating the gas in the closed container is an isochoric process. Heat capacity of the Q is equal to mCp into delta T here. That is the second law of thermodynamics. Heat does not flow from a low temperature to the high temperature operation without aid of some external energy. That is a Kelvin Planck statement. It is impossible to extract the amount of heat from the low heat reservoir and use it all to do like some amount of heat must be exhausted to the cold reservoir. And it means the efficiency of heat engine is never 100%. This is the second law of thermodynamics, that is entropy is equal to, it is the ratio of delta Q by delta T here, that is the cold and hot reservoirs, and how the heat is transferred from high temperature to the low temperature, and what is the relation among entropy, heat values, and T values. Delta S is equal to Q by T here, and the internal energy is defined. The energy is associated with the random and disordered motion of the molecules. And the heat engine, it is the heat engine is a mechanical device which produces the heat energy is converted into the mechanical energy, and the efficiency is the heat in the work net work done, net work done by the heat input. Net work done is heat input to the heat output, so that the efficiency of the heat engine is equal to 1 minus of q out by q heat low heat value to the heat input. So, with this, the basics of thermodynamics. Thank you all for peaceful, for careful listening.